The following is the learning objectives and details of this module. Please read it carefully, and let's start. A voltage drop test is a circuit diagnosis method that applies the Ohm's law. You can't say that a circuit does not have a problem just because the appearance of its connectors and wiring looks okay. A faulty connection, aging of wiring, and loose ground bolt can generate unwanted resistance in the circuit. This resistance hinders the flow of current, causing unintended voltage drop. A voltage drop test is designed to find the voltage drop that is not supposed to happen on a normal circuit and find out the cause and location of the problem. The voltage drop test is usually carried out when the load does not operate properly. You don't need to disconnect other circuits for measurement, so it can be carried out easily. By using the voltage drop test, you can find out abnormal circuit failure cases, such as a faulty connection and aging of a connector or switch. Voltage drop occurs in every load. It not only occurs in general loads, such as a light bulb and motor, but also in switches and wirings. However, switches and wirings in normal conditions have very little resistance compared to general loads, so the degree of voltage drop is very small. Next, we are going to look at the circuit that we usually find on the vehicle. When the circuit is normal, the switch is closed, and the load is operating, we will see how voltage drop occurs on the vehicle. You can see that most of the voltage drop occurs in the light bulb, which is a general load. If voltage drop occurs in wirings and switches, it means that there is a problem on the circuit. The circuit you are now looking at has faulty wiring. We will measure the voltage drop by using the same method as in the previous circuit. The measurement shows that aging of the wiring caused the voltage drop. Since unnecessary voltage drop has occurred on the wiring, relatively small amount of voltage is supplied to the light bulb, lowering the brightness of the light bulb. This circuit has a failure on the ground side. We will measure the voltage drop by using the same method. We found an undesired voltage drop on the ground side. Likewise, a small amount of voltage was supplied to the light bulb due to unnecessary voltage drop. For the record, voltage should be measured as 0 volts on every point of the ground side. If it is not measured as 0 volts, it means that a problem has occurred on the ground side. This circuit has a faulty connection on the switch side. An undesired voltage drop has occurred in the connector. It is not easy to find this kind of problem with the naked eye on an actual vehicle. We will measure the voltage drop in each point of the circuit and find the point where a problem is likely to have occurred. The amount of voltage drop is very small in a normal circuit. However, in this circuit, the voltage drop has occurred due to the aging of wiring between the load and switch, and this has diminished the overall load performance. When you carry out a voltage drop test, you should first check if the circuit is closed. A voltage drop test is meaningless if it is carried out on an open circuit where current does not flow. Second, the voltage drop test should be carried out both on power and ground sides of the circuit. If a voltage drop occurs in a certain area, you should narrow down the area and find the specific area where the problem has occurred. Third, you should check if problems exist on the circuit by using the voltage drop test before replacing expensive battery or alternator. Fourth, you should keep on practicing. In order to narrow down the area and find the specific area that has a problem, you need to build up enough experience. First, we are going to look at the characteristics of an open circuit. Since current does not flow on a disconnected circuit, the load does not operate. This problem usually occurs due to damage in the fuse or relay. Also, when you measure the voltage, power voltage is measured before the disconnected area, and ground voltage is measured after the disconnected area. In this case, check for the disconnection by measuring the resistance. It can be determined as a disconnection if resistance is measured as infinite. The circuit you are looking at does not have a disconnection, but its switch is open, so the symptom is similar to a disconnection. Now, we are going to carry out the measurement. First, we will measure the voltage of the closed circuit for comparison. You can see that the load is operating normally, and the power is used up by the load. Next, we will open the switch to create a disconnection, and then measure the voltage. You can see that the load is not operating, and the power voltage is standing by right before the opened switch. Next, we are going to look at the circuit where an open circuit has actually occurred. There is a disconnection between the battery and load. The switch is closed, but the light bulb does not turn on due to the disconnection. You can see that the battery voltage is measured before the disconnected point, and the ground voltage is measured after the disconnected point. In order to clearly see if it is disconnected, you should check the resistance of the section. For your information, you may use the test lamp instead of a multimeter when you only check the presence of voltage. If a short circuit occurs, various kinds of symptoms may occur on the circuit, depending on the location of the short circuit. To learn about the characteristics of short circuit, we will check the symptoms that occur depending on the location of the short circuit. So far, we have learned about the characteristics of short circuit. If you become familiar with these characteristics, you can easily identify where a short circuit has occurred. The following circuit has a short circuit to the ground between the fuse and load. In this case, you can easily determine that the short circuit occurred because the fuse keeps blowing out. Then, you should find out the location where the short circuit has occurred. You can do this by measuring the resistance. Remove the connector on the area where the short circuit is suspected and measure the resistance with the vehicle body ground. If the circuit is normal, infinite resistance is measured since the connector is removed. However, in the case of a circuit shorted to the ground, 0 ohm is measured. For the record, what we have learned so far was about a short circuit to the ground. Rarely, power short circuits may also occur. In this case, power voltage is measured in the middle of the circuit. Inspection using current measurement is not carried out as often as the inspection using voltage measurement. Charging current measurement and dark current measurement are main inspection items for current measurement. Charging current measurement can be carried out by using the hook-type ammeter. Dark current measurement can be carried out by measuring the current between the negative pole of the battery and the ground connection terminal. Please review the lessons you've learned in this session through simple quizzes. Please review and memorize the contents you have learned so far.